Hi guys, today we're going to be looking in detail at sedimentary rocks because sedimentary rocks are very useful in interpreting Earth's history. And sedimentary rocks can have all different sorts of appearances. These are sedimentary rocks at Dead Horse Point State Park in Utah. These ones are in Petrified Forest National Park. And these are on the island of Rügen in Germany. And each one has different characteristics and different compositions. And by looking at those very unique sedimentary rocks, we can tell what the environment and ecosystems were like in the past at those locations. So that's what we're going to be learning about today. So the type of sedimentary rock that's formed in a location is affected by many different aspects of geology. The tectonic setting can affect it. Are we near a mountain building event, or are we in a quiet area of a continent? What type of rock is being weathered? Remember, sedimentary rocks are made out of the weathered parts of older rocks. Well, what are those older rocks being weathered? Is it granite? Is it basalt? Is it other sedimentary rock? That's going to affect things. The transport medium. This basically means what is picking up those particles of sediment and carrying them around. Is it water in a river? Is it along a beach? Is it wind? Is it ice? What is moving those things? What processes are happening in the depositional environment? So when that sediment gets dropped off somewhere, what kind of biology is acting in that area? What are the physical things going on there? What's the climate like where this rock happens to be forming? And then what kind of processes does that sediment undergo in lithification? And remember from physical geology, lithification is where the loose, unconsolidated sediment gets turned into solid rock. And this is done through compaction and cementation. And just how much compaction do you have? How much cementation? What kind of cement holds that rock together? These are things that affect the characteristics of those rocks. Then also, how much time is available to form that sedimentary rock? So there are many things that go into creating these unique sedimentary rocks all over the world. So let's look in detail at some of these and how they affect the rocks that are created, and thus what observations can we make about these rocks in order to interpret Earth's history. So the tectonic setting. This is the deformation and structural activity of a region of the Earth. So really we're looking at, are mountains being formed? Is a basin forming? Is this an active plate margin or a passive one? Things like that. So mountains in uplift, how does that affect it? Well, for example, this is looking at some sedimentary rocks going all the way from Pennsylvania into parts of Canada. We had mountains forming over here, and then right next to the mountains we have sandstone and conglomerate. A little farther away we have just sandstone, and then as we get even farther from the mountains we have, for instance, finer grained sedimentary rocks. So what does the tectonic environment, how can we interpret things? Well, when we have this uplift of the mountains, closest to the mountains where we have this weathering of those and not a whole lot of transport, we get coarse-grained sediments like breccias and conglomerates. And as we travel farther and farther from that uplift, we get finer and finer grained sedimentary rocks. So this can kind of help us interpret where ancient mountain ranges were being built. Now also when we're looking at tectonic setting, we need to take a look at depositional basins. And my cat has an opinion about depositional basins. Now, so a basin is a place where part of Earth's lithosphere is subsiding. It's dropping downwards. And these basins allow for very thick sequences of sediment to accumulate, right? Because it's this lower area, that's where water and rivers and things are going to be flowing, so that's where your sediment is going to get carried to. Now, the sediment supply, so the amount of sediment that's being carried to the basin and the rate of subsidence is going to affect the type of sediments you get. So, for example, this is from the Albuquerque area where I used to work in New Mexico. This is actually from one of my publications. We had a basin that was subsiding along a fault, right? This whole thing was dropping down, and sediments are being washed into that area. So depending on how fast and how much this basin dropped, allowed greater areas, greater volumes of sediment to accumulate in there. So you have this kind of interplay between tectonics and the supply of sediment, resulting in exactly where your different sediments were accumulating in the basin. You see here we had 3 basic types of sediments, and depending how this was dropping down, depended exactly where these were being deposited. Now, when we talk about continents where our sediment is eroded from, there are some basic parts of a continent, and I know I go over this a few times, but that's because it's important. We have the craton. And the craton is the stable interior part of a continent. And in this craton, we have what's known as the shield. And the shield is where your old Precambrian rocks are exposed. Now in the craton, you also have the platform. And this is where those old Precambrian rocks are hidden under younger sediments that have accumulated. And you also have orogenic belts in a continent. Now, some of your older historical geology textbooks might also call these mobile belts. Don't get confused by that. Mobile belt or orogenic belt, basically the same thing. This is a region of significant Phanerozoic deformation. So, a place where we've had significant mountain building events in the last, say, about 500 million years. And remember, orogeny is a mountain building event. That's why we orogenic belt, same root word there. So in this diagram right here, this is North America, and we can see the shield right here and the platform, which makes up the North American craton. And then we have these orogenic belts of the mountain building events that have affected the area. All right, so I said depending on all kinds of different characteristics, you have sediment accumulating in different places on the planet. And the place where sediment is deposited, where it builds up and accumulates, is the depositional environment. When we study this, we are looking at all the environmental factors under which the sediments form. So physical, chemical, biological, all of the influences to the type of sedimentary rock we're ultimately going to get. This diagram here gives you a good idea of how varied these depositional environments can be. And so we have some that are in the oceans, some that are on land, some are in the deep oceans, some are in kind of mountainous areas, some are in coastal areas, and depending on those different environments, you see different rock types forming. So for instance, in a sandy desert, we get sandstone. In a desert lake, we get rock salt and gypsum. In a reef, we might get some, limestones forming. So these different environments each have characteristic sedimentary rocks that form. And that's why I can travel to places, I can look at the sedimentary rocks and I can say, once upon a time there was a river system here, because river systems have certain rock types. Or I can say there was once a coral reef here, or there was once a desert here, because by looking at those specific rocks, you get to have a window into Earth's past. So let's look at these different depositional environments and the rock types that form there. And we're going to start with continental environments. So these are going to be places on land, on the continents. And many of them have fancy geology terms to go with them, like fluvial. Anytime you hear the word fluvial in geology, we are talking about river systems. So if you hear me say those are fluvial sediments, they're sediments dropped off by a river. Now, fluvial sediments can be very complex depending on the type of river you have. Remember, from physical geology, you had meandering streams, but you also had braided streams, then you have some types of streams that we didn't even talk about in physical geology. And so you can have all kinds of different sediment. You can have gravel size, right? Big particles. You can have sand, you can have silt, you can have clay. And it all depends on, are you looking in a fast-flowing channel? Well, then you might have the coarser grained sediments. Are you looking in a floodplain where you have very low energy and you have standing water at times after floods? Well, then you might have silt and clay. So you can have in a fluvial system channel deposits, floodplains, point bars. You can have all kinds of different sediments to them. And what we're looking at here in this photograph, these are sediments of the ancestral or ancient Rio Grande, and this is in New Mexico. And the white down here, these are older sediments. And what we're seeing right here, this is what's called a cut and fill system, where some fast-flowing water in the river actually eroded away some of these older rocks and then filled that eroded area with sediment. And that's something you often get with river systems. You also, in river systems, often see these smaller crossbeds. And these are formed as a current, right? The river flows with a current. Well, the current creates these smaller crossbeds, and that actually lets us know what direction the river was flowing. So later on in this class, when I say things like, in the age of the dinosaurs, there was a river flowing westward across New Mexico. Well, how do I know that? I know that because I can see things like these crossbeds preserved in the rocks. These, that's a lot of mudstone and siltstone, and that's very typical of floodplains. So floodplains, basically when the river floods and then the flood goes away, you have a lot of standing water in these areas. It's very low energy. You get the finer grained sediments there. So hopefully your take-home message is fluvial sediments can be quite complex, and very commonly I'm going to see channel deposits of coarser grained material and then floodplain deposits of finer grained material. Now, also in a continental environment, you can get alluvial fans. And remember, from physical geology, an alluvial fan is where a stream is flowing from the mountains, where there's a really steep slope, so there's lots of energy for the stream to transport sediment, but then it flows into a flat valley. And now it's flat, the stream loses its energy, and so it drops off all the sediments that it's carrying. And in these alluvial fan deposits, you will have gravel, sand, and silt, and it really depends on what part of the fan you're at. Remember, higher energy water can carry bigger particles, so oftentimes, right where the river flows out of the mountains, that's where you get the gravel, right? The coarsest grain stuff. And then as the river's slowing down, as it flows away from the mountains, it's going to lose its energy, and it's going to then drop silt lastly. So this is an alluvial fan in Death Valley National Park. We have a little river or stream, and of course this is in the desert, so it is ephemeral. It's not always flowing. Usually in like springtime when the snow melts from the mountains, it flows. But when it's flowing, it flows through here, and this is the alluvial fan that's created, right? It has that nice fan shape there. Like I was saying, right where the water flows out of the mountain, that's where you would tend to have your gravel. And then as the river's slowing down, as it gets to the edge of the fan, towards the edge is where you tend to have your finer grained material. Alluvial fan deposits look a lot like this. This is an alluvial fan deposit off in New Mexico. We can see large pieces, large clasts in there that were carried out of the mountains and deposited on that alluvial fan. And that's something very typical in these deposits. All right, here's another fancy geology word, lacustrine. Lacustrine refers to lakes. And in your lakes, silt and clay are very common because in the center of the lake you're not going to have very high energy currents or systems, so you tend to get the finer grained material settling. However, the sediments do vary depending on the depth of your lake, how large your lake is, and the influx of sediment, like how much sediment is being carried by the rivers that are emptying in the lake. Then of course it also depends on, are you right at the shoreline of the lake or are you in the center of the lake? All those sorts of things will affect the type of lacustrine sediments you get. Now, lakes often contain really, really nice fossils, and that's because when you have finer grained sediments, you often get better preservation of fossils. And I know we haven't had our fossil lecture yet, but we're going to talk a little bit more about that when we get to the fossil lecture, about just how fossils get preserved. So these are some lake sediments from Lake Tecoma, which was a lake that existed in California during the last ice age. And so we see a lot of these just kind of fine-grained lake basin sediments. Another lake that existed, this one all the way back in a time period called the Eocene. This was in Wyoming, and it created a rock formation called the Green River Formation. And like I said, in many cases, lakes, because of the fine-grained sediments, preserve fossils really nicely. We can see some fossils of fish. There we have a fossil of some kind of a snail. And this is a bird that basically died and fell into the lake and got preserved in the sediments as well. Like I said, we'll talk more about how fossils are preserved in a few more lectures. All right, on continents, we also get glacial sediments. Glacial sediments are basically things that are deposited by massive ice sheets. Right? Glaciers are these thick masses of ice. They might be 3-4 kilometers thick. They grind up the rock underneath them and produce a whole lot of sediment. And glacial deposits can be quite complex as well. You can have gravel, you can have sand, you can have silt, you can have clay, because around glaciers you have till. This is the material that's deposited directly from the ice when it's melted. And ice can pick up boulders the size of, heck, it can pick up boulders the size of houses and drop them off. But ice itself can carry every different type of sediment, big, small, all sorts of things. So then when the ice melts and it drops off this till, you get this very unsorted material. Unsorted means all different sizes and shapes. And it's also unstratified, meaning we don't see any layers in that. And that tells us this sediment was dropped directly by ice. But glacial sediments can also be made from stratified drift. Well, ice is frozen water. As that ice melts, you're going to get a whole lot of water flowing in the area. And that meltwater can create stratified drift. And the stratified drift is going to be sorted. It's going to have certain sizes of sediment in it, and it's going to be stratified. It's going to have layers in it, like what we see right here. This was created by meltwater from a glacier. Now, as I said earlier, glacial deposits can be very complex, depending on, are we at the edge of the glacier? Do we have streams coming off the glacier? Sometimes the glaciers have, they dam up areas and create local lakes. And so you can have these kind of glacial lake deposits that have all the characteristics of lacustrine sediments. So you can have very complex sediments formed around glacial areas. And in fact, right here, these are sediments of the glacial Lake Thompson, which is up in British Columbia. It's a place where a large glacier actually dammed up an area and created this huge lake for a time being. And so glaciers can, just like other sediments, be complex, but if we look at the details in those sediments carefully, we can really get a nice picture of what Earth looked like in the past. And that's one of the keys to studying and understanding historical geology.